Construction sites generate a tremendous amount of waste, most of which ends up in backfilling. But what if we could design new buildings using reclaimed materials?
That's where reversible BIM comes in. Reversible BIM uses the building information model to analyze the technical reversibility of buildings and recovery options of building components and materials by assessment of technical and physical dependencies. The reversible BIM model contains information about the specific materials used in each component of the building and how those components fit together.
For each component, a reuse score is calculated and displayed as a color scale from red to green, with a value of 0.1 to 0.9.
In order to apply RBIM,
The existing building must be digitized. The starting point for the model is a 3D scan, which is used to create a base model out of a point cloud. In the base model, the connections between the components are analyzed.
overall, reversible BIM models that prioritize material reuse can play an important role in promoting reclaimed materials in construction and reducing the environmental impact of buildings.
So my name is Elma Dumicevic. I'm founder of a laboratory for green transformable buildings and founder of 4D Architects. I've been working in the field of circular building for more than 20 years, finishing my PhD at Delft University of Technology, which was a starting point with defining the transformable building structures as a core of this research. And since then, I went on then working with construction industry and trying to help industry itself to start transforming the way they process materials, the way they develop products, in a way that we can really start seeing buildings in a different way as more dynamic structures built up of reusable and reconfigurable parts. And the reversible BIM is basically doing digital assessment of reversibility of the building and the reuse potential of elements in a building. And it does so by literally trying to understand the relations between elements which are brought into a building, how many connections these elements have, what type of connections, what is the hierarchical order of bringing them together or dismantling them, the technical life cycle, the remaining life cycle, and then putting all that together, the calculation comes up, identifying the reuse strategies for individual elements within a building, and also informing the users on the capacity of the reuse capacity of building and materials in their percentage of how many materials can be reused by reparation, how many materials can be reused by remanufacturing, or materials which have no really future value through reuse but need to go to recycling streams. So that's kind of overall view on how a reversible BIM works. This using scan files from a scanning module, which is also on the platform, and doing the analysis of dependencies within a building, also using some technical information and drawings of the existing building, and defining this reuse capacity by doing the digital inventory of building and its materials.
So, we use a digital tool which is the BIM model, but this may seem a bit strange, as actually we create a BIM model to then dismantle a building, to deconstruct a building. Until now we talked about BIM to build, now we talk about BIM to deconstruct. But for an engineering office, it is a great time saver to be able to navigate in a model without having to permanently come back on site and analyse the elements. The goal of still being able to identify all these elements and to be able to build a database.
We have incorporated the Autodesk 3D Viewer into the DDC platform, so any BIM model can theoretically be imported and visualized here. However, each project owner has to connect its own Autodesk application, which hosts his BIM models. We currently show an IFC model of the building to deconstruct. We call it reversible BIM because it also contains information regarding the reuse potential of the building's constituent elements, the outcomes of the reusability analysis by one of the platform modules. You can find out more about this on the DDC website. I can now switch between different views using the buttons on the right-hand side, so I can see the reusability indexes of my elements.